So I knew it was going to be hard to reconvene the group after three governors' remarks, a signing of a historic document, and a break. But I think we have a really great panel here this afternoon on research and innovation. And I think it is one key piece of this cog that we want to definitely talk about. So I'll first introduce myself. I'm Brian Anderson. I am the director of the WVU Energy Institute at West Virginia University and the GE Plastics Materials Engineering Professor of Chemical Engineering in the Statler College of Engineering and Mineral Resources. In my role as the director of the Energy Institute, we are a land-grant school, and so part of our mission at the university, at West Virginia University, and within the Office of Research and Development at the university is to spur on economic development. That is sometimes lost on the land grant mission, but as my boss, E. Gordon Gee, the former president of Ohio State and current president of West Virginia University, often comments, it is a key part of the land grant mission is this economic development. And for us in the region, and in particular us at West Virginia University, our role within the state cannot be understated. And so what our role is both in research and innovation and education and in workforce development. And so our universities and research entities around the region play a key role in a lot of the things that we've talked about today. And we've started with the opportunity that is presented before us in terms of the shale gas revolution that we've all seen, and we all know what that means and what opportunities may lie ahead of us. But now there's a key challenge, and that key challenge is to take this resource and be good stewards of that resource and develop regional economics, and a lot of that will come in the form of developing new products and new processes. And so today we want to showcase some of our regional universities as well as regional research institutions that focus largely on research and innovation and commercialization. And so I'll introduce my panelists here in a little bit, but since I have the stage and the microphone, I first want to welcome you again to Morgantown, welcome you to West Virginia, and really have been excited about what has happened today. It's been months in the making, and I have a lot of people to thank for helping us put the panel together and helping us along the way, including LaDotta Taylor and the Adventure Group and Corey Dennison and the folks at Team NEO, Paul for sure, as well as Jobs Ohio and of course the Benedum Foundation Allegheny Conference. And so if we bring up my slides, I want to talk a little bit, just set the stage on what the opportunity is that's presented before us. And in research and innovation, there's a real opportunity now. We have low energy costs. We have raw materials that are the cheapest in the world when it comes to methane and ethane. But what are we going to do with it? What types of products are we going to develop? We can definitely build the cracker facilities, but we need a much more diverse portfolio. And so that's where research and development and innovation really comes into play. And so to give you a quick background on the Energy Institute, we have focus in research and education as well as campus sustainability. And in that research and education piece, that's really what we're discussing today. So we have a lot of broad areas of energy research across the university. It's in fossil energy and sustainable energy, as well as policy and the environment. And so there are about 150 researchers, faculty members at the university doing energy research in all of these different areas. And it's our job to try to take these innovations that our students and our faculty come up with and move them into the market. And that's what we want to focus the panel on today, is how we can interface with industry and with government and academia so we can push forward processes in economic development specifically enabled by this shale gas revolution. And so shale gas, we at WVU think all the way from supply through demand. Diane Anderson mentioned this morning a project we have with Ohio State that has come out of a memorandum of understanding signed a few years ago, I guess 2.5 years ago now, that allowed us to focus on 5 different research areas, all related to shale gas, in a collaborative project between Ohio State and WVU. And this partnership, it's in, as I show here, in the subsurface in producing the natural gas, in utilization, which is the focus of what we're doing here. But as has been brought up a couple times today, environmental stewardship is a huge piece of this, as well as policy and the economics. And so we really need a very well-rounded, and I'll use this word a couple times, innovation infrastructure for the ecosystem of innovation. And this includes all of these different areas. And so I actually wasn't planning on mentioning a whole lot about the Marcellus Shale Energy and Environment Laboratory, this collaborative field project with Ohio State. But when Diane mentioned it this morning and said I was going to talk about it, I decided, well, I guess I need to. And so this MSEAL project, the Marcellus Shale Energy and Environment Laboratory, it's a long-term field project funded by the Department of Energy with our cost-share partners and industrial partners, Northeast Natural Energy and Schlumberger. And this project is really the first of its kind in the world. We have just about 1 mile from here is the Marcellus Shale Energy and Environment Laboratory. It's 2 production wells and a science well in the Marcellus, where we're studying the environmental impact as well as ways to increase the efficiency of production. And it's an exciting partnership and an example of how when universities can collaborate and get together, we can create something that is quite large. The second project in this collaboration is the Utica Shale Energy and Environment Laboratory. And I know earlier today I saw Jeff Daniels from Ohio State, who's the head of the Ohio State project. But it's a very similar project focused in the Utica. And this is a tremendous opportunity, and we thank the Department of Energy for the opportunity to lead this project and to do something so cutting edge. Those wells were in fact, the 2 production wells were drilled and completed just last week. The original plan was that stimulation on the first well was going to start today, but it shifted a week, so you missed it. We're going to roll out all the completion and stimulation equipment out next week. So this laboratory, the vision is that it's a long-term, cutting-edge, state-of-the-art, long-term laboratory where we can study the environmental impacts as well as environmental impacts of shale production, as well as develop new technologies to both minimize the footprint, minimize the truck traffic on the upstream shale gas development. And this is really important as we've heard over and over again today that the long-term potential is vast for shale gas production in this region. And so focusing on decreasing the environmental footprint is really, really important. Just to give you a map of where this production well is, here you're looking at the river. And it's going to be really hard for me to point it out, but we're just about right there in the hotel. The NETL is just north of us, a couple of miles, and then the wells are just south down the river, just upriver from where we're sitting right now. There are 2 production wells that were previously drilled in 2011, and then the production wells that were just recently drilled over the last couple weeks. In the box in the middle is actually the science observation well, where over the next 5 years we'll be able to get lots and lots of data. And that'll come back, as Roger French, one of our panelists, will talk about a collaborative project where Case Western is involved in this as well, in data analytics. So those research areas are in the subsurface, they're in environment. We have air and water quality monitors all around this region. There's an air quality monitor, I believe, on the parking garage just outside the hotel, where we're measuring every drop of emission that may come from this well site so that we can minimize the environmental footprint. But today is more about utilization and what we're going to do downstream. And so we've embarked upon an initiative called the Shale Gas Utilization Mountain of Excellence. And we are here in the mountains of Appalachia. And this Mountain of Excellence is specifically designed to create a robust infrastructure of research in this area of shale gas utilization. And so we've hired faculty members all across the university in policy and in law in finance and business, in chemical engineering and mechanical engineering, all specifically designed to focus around this area of the business and economic opportunities, as well as the technological advances that we can push forward in research and innovation to utilize our natural gas in this region. And so one question that has come up, and this is similar to the Mark West talk this morning, in terms of what is this opportunity, is it real, and how long is it going to be around? And what I'm showing you here is the Brent oil spot price over the last 15 years. And you all recognize first the spike in around 2008. We remember the spike in oil and gas prices. We saw it at the pump. And then the prices dropped. And then we saw another spike over the course of the last few years, and then a precipitous drop last fall. And so this is something that is very worrisome in the industry, particularly if we're making the decision to build a cracker facility where two of our raw materials might be either naphtha or ethane. And so the economic and business decision comes down to building your plant as naphtha versus ethane. And so the price point that you actually follow is this oil-gas price ratio. And so that's what I'm showing here in the blue curve. So the red line, which hasn't moved a whole lot over the last 15 years, is the price of natural gas. The blue line is that oil to gas price ratio. And if you notice, before 2008, that price ratio stayed somewhere around $10, or a factor of 10, is a 10x. And that price ratio is actually a barrel of oil versus a million BTU of gas. And the reason this is important is the natural energy content within natural gas versus oil, that price ratio should be about 6. So anywhere between 6 and 10, all that is just in the statistical noise in effect. But notice something happened in 2008. And in 2008, that oil to gas price ratio changed, and it changed dramatically. And the reason it changed was the Marcellus. It is really the sole reason that change is the shale gas boom has separated the oil and gas price ratio. And notice, even in last year, when the price of oil dropped from over $100 a barrel to 45, that oil to gas price ratio only dropped to about 25. Now the story I'm leaving out here is that this gas price is Henry Hub. And the problem with showing this is, as we saw this morning, the price of natural gas at Henry Hub is not the same as it is in the Appalachian Basin. So if I showed you this chart for the Appalachian Basin, the oil to gas price ratio is 40, which means if the natural price ratio is 6, at 40, we are 7 times discounted over oil as a price. And because we have now coupled the ethane and methane prices, this is the opportunity that's in front of us. This is the opportunity that now we have methane and ethane and natural gas liquids as a raw material to play with. And for those of us in the research industry, that's what we like to see. Now we have a raw material that can compete with anything in the world. It's the cheapest gas on the face of the earth. Now what are we going to do about it? And so here's what I propose we do. Yes, I wanted to laugh. So what I propose we do is everything. This raw material can be made into almost any manufacturable plastic. It can be made into tires and whatnot. And so everything that is pink on the upper side of this graph is natural gas and natural gas liquid. It's what we're getting out of this region in the Marcellus and the Utica and the other shales that we can produce. And if you follow the pink boxes, and don't worry about what's in the box, if you want it, email me, I'll send you this chart. I've already promised a few people today. And so what's in here is everything that is roughly pink is what we can make from natural gas. And so the point is, it's not just crackers. It's not just polyethylene, it's not just polypropylene. We can make a world of products from what we are producing on the Marcellus and Utica, and it's up to us in research and innovation and commercialization to design those processes, to make new catalysts, to commercialize these multitude of products, which if we use natural gas, so this is really just looking at the natural gas piece, we can make almost anything out of this raw material. And so that's our job. And we have significant R&D efforts that remain. It's in process synthesis and reaction engineering and catalysis, and there are some grand challenges that are now enabled by computational capabilities that we have across the region in the universities and our innovation centers. And so our utilization efforts at WVU, we're looking at all kinds of different things in catalysis, direct use natural gas fuel cells, natural gas combustion, as well as gas to chemicals and gas to liquids, all driven by a lot of different basic science needs, but with a industry pull that will drive us toward commercialization. And so finally, I now want to quit talking and start discussing with our panelists, and I will introduce all three of our panelists now and ask them to come up and give a few remarks, and we'll have some questions and answers. So our first panelist is going to be Mark Redfern, who is the Vice Provost for Research at the University of Pittsburgh. I've mentioned this is a tri-state effort, so you'll see we have representatives from all three states. Mark leads the strategic research and development as well as the Office of Research at the University of Pittsburgh, and he works closely with what is called the Innovation Institute to support translational research and entrepreneurship support at the university. He is also the William Kepler Whiteford Professor of Biological Engineering with secondary appointments in otolaryngology, physical medicine and rehabilitation, physical therapy and rehabilitation science. So he wears about, what, 6 hats? Something like that. He has a Bachelor's of Science in Engineering Science and Master's and PhDs in Bioengineering from the University of Michigan. Our second panelist will be Roger French, who is the Director of the Solar Durability and Lifetime Extension Center at Case Western University. He's also the Alex Nason Professor in Materials Science and Engineering at Case Western with secondary appointments in macromolecular science and physics. So as you see, we get people who are really multidisciplinary here. He's also a member of the Department of Energy Basic Energy Sciences Advisor Committee and previously was in Central R&D at DuPont Company and an adjunct professor at the University of Pennsylvania in materials science. Our third panelist is Greg Clutter, who's the Chief Operating Officer of Matric. That is the Mid-Atlantic Technology Research and Innovation Center. And I'm going to have Greg explain why we have 3 academics and then Matric, because it's a really key piece to this puzzle within the innovation ecosystem. So Greg is also the Executive Vice President of Matric and joined Matric in 2008 as Director of Commercialization, and that is the key. So what we're talking about here is how we can get things to commercial products. He was promoted to Chief Operating Officer in 2011 and was previously the Director of Innovo Commercialization Group at the West Virginia High Technology Foundation, also previously with Nortel Networks and the Research Triangle in North Carolina, as well as Deloitte. Greg has an MBA from UNC Chapel Hill and is a Mountaineer graduate in business administration from WVU. So first, I would like to welcome to the podium Mark Redfern from University of Pittsburgh.
Well, good afternoon. It's great to be here, and I'm putting on my Vice Provost for Research hat and not all those other hats that I have today, and talk to you a little bit about the research at the University of Pittsburgh in this space of downstream natural gas. And then at the end, I'll talk just one slide on some thoughts about how we can work with industry more effectively to promote research and move this field along. So if I keep pushing buttons, I'll eventually hit the right one. There we go. Okay, so I'm going to talk about, for just about 5 minutes is all, 3 areas where the University of Pittsburgh is working in research in downstream natural gas. There are some other areas as well, and a lot of areas upstream in water, sustainability, and drilling, but I won't focus on those today. I'll just talk about these briefly. The first one is energy-intensive manufacturing that requires lots of energy and some novel ways we're thinking about that. The second one is utilization of new products, which you've heard a lot about that here today. And then the third one is applications in additive and advanced manufacturing. So the first is in energy-intensive manufacturing. And one of the things that we're looking at now is what's called combined heat and power work. And so Greg Reed, who's our director of the Center for Energy, is looking at that. And how can you use this very inexpensive fuel to not only do manufacturing, but also use the byproduct heat that comes off in a coordinated way. And so we're doing that with a number of industries, looking at the possibilities to do this in the future. The second area that we're really focusing on is catalysis. So one of the things that we've decided is that one of the rate limiting steps in developing new products is catalysis and new catalytic materials to develop different kinds of products. And it's been interesting how this group has formed here at the University of Pittsburgh. So if you see the top, we have a number of faculty who are computational modelers. And so what they're all doing is developing computational models for materials to have possibilities of new types of catalytic materials in this space. So we've got a lot of senior folks in chemistry. We just hired John Keith there. He's actually an R.K. Mellon fellow that we recruited about a year or two ago with some support from the R.K. Mellon Foundation, and has been tremendous in this area. Then down on the left, we have what we call the makers. These are the folks that actually make some of the catalytic materials based on the computational side. And then on the lower right, we have the measurers. So these are the folks who look at the surface characteristics of some of these materials and try to explain why or why not they're doing what they're doing in the experiments. So, and it goes around in a circle. So all these guys have to be coordinated in order to make this effective. And it's been a lot of fun watching them interact and where they normally wouldn't have interacted prior to this. The third area I'll just briefly mention, and we can talk more about it at the panel, is additive manufacturing and advanced manufacturing. So as we all know, additive manufacturing is allowing us to design and build parts in ways that we couldn't have before. So in old manufacturing, there were certain constraints on doing design to be able to make it. And nowadays, we can have all new designs, and we can actually make these parts. And so now, the folks at the University of Pittsburgh that are working in the space are thinking about how can they apply research in additive and advanced manufacturing for catalysis and other kinds of areas within the natural gas space. And so it goes all the way from the part itself and the design of the part and the surface structure of the part as well. So it's been pretty exciting to see that field, which is fairly new in and of itself, spanning out into this space. Finally, my last slide. As Vice Provost for Research, my job is to figure out ways to do things better. And one of the ways I think we're going to be successful in making progress in the downstream shale gas is to partner with industry. And I think there's a lot of ways we can do that. Some of these ways we've done in other sectors in our past. The first one is just collaborative research, collaborating with the scientists and the engineers at the companies. The second one is co-locating scientists. So maybe we send a scientist to your company. If you have a company doing R&D, maybe you send a scientist to us. We've had great success with that in other materials types of companies and problems. And it develops a long-term relationship, which is beneficial to both. The third is shared facilities. If there are facilities that are too expensive for a company or a university to have, maybe combine and put a facility together. Funding specific research, that's sort of old school, where industry funds specifically what they want to accomplish, and we serve that purpose. Partnering for external funding is something we've done in a few energy sectors, where we would partner with a company and go after federal money. And so that federal money then would flow to the company, and it would also flow to the university, and we would work in a coordinated fashion on a problem. And so you can get fairly large money, so you can do actually fairly large projects that way. And finally, implementation projects where If we have something to implement, it would be implemented in the company with support from the university to put it in, also do some measurements and help with the analysis of that area. So I think there's lots of things we can do. At the University of Pittsburgh, we've got a number of areas that we're excited about moving forward, and we're really interested in partnering with industry and other groups interested in the same kinds of things. Thank you.
So it's a pleasure to be here today, and I just wanted to do some opening comments to sort of set up some of the opportunities for helping accelerate innovation because of data science and analytics applied in these areas. It's one of the things that can be very, very helpful. And so I'll give you a little bit of a context of that. And so I'm at Case Western Reserve University, and we have a Great Lakes Energy Institute, which Diane Anderson used to be the executive director of. It's been around about 7 years. Those kinds of institutes are things that help integrate both interactions with industry and with the federal government, and even with the community resources and innovation hubs. What I'm going to do, though, is really be focusing on these energy data science and analytics examples, which apply really quite broadly and bring in all kinds of, they almost are served to be a uniting part of what we do. So Great Lakes Energy Institute works in both future power, so that would be all the electricity grid and areas of efficiency and generation like that. Energy storage, solar energy. This is a bunch of work that we do in our research center. Wind and oil and gas, and I'll show you some of the oil and gas things that we've been starting most recently and in collaboration with WVU and Tim Carr here and SCL. And one of the cross-cutting things across all parts of this for us is this energy data science and analytics. Basically nowadays, starting only in the past 5 or 7 years, not possible before 2006, the things that Google has innovated in computation and allowing distributed computing and being able to index the whole web are things that we can bring to bear in engineering and into energy sciences. And these are something which transform all the ways that you look at. You can now use communication and computation to study all of the power plants in the world and see what they're telling you, instead of having to just restrict yourself to experiments in your lab and then infer how power plants you've never looked at might behave. So it's a really big change, and with the gigantic changes in shale and drilling and uses of these materials here as we're getting going, this is a perfect opportunity to start to bring to bear some of these things. GLEI over the past 7 years then has gotten very good funding, and so for example in my research center, GLEI helps us a whole lot. We have half of our funding from industry, half of our funding from the federal government. Let me back up. There we go. The stakeholders, it helps integrate and sort of bridge some of the barriers in the university, and also it makes that the teams can be put together that are much more appropriate to the opportunities that we have. And then we actually end up having some real impact, both in industry and applications and science, even in the policy areas. So let me show you about this energy data science and analytics. Okay, and so this is going to be the one where we can now do what I refer to as scalable analytics. So when I first came 5 years ago to Case, I knew this is what I was going to pursue, but I couldn't get any of the people working on PV power plants to give me their data, because their first response was, well, that's my data, it's proprietary, I can't share it with you. So what I did was that I went and built 122 power plants on campus in a 1-acre outdoor test facility with 20 different brands of modules, and I started studying them. And then we started publishing papers. And all of a sudden, what started at one site, the only one I could afford to build, grew into a set of 12 sun farms, both in Cleveland, in Ohio, in the United States, and over in Asia and India, where other entities kind of said, well, we'll build one of those outdoor test facilities and ship you the data if you could help us understand it. That really helped us, you know? But now we even have a new set here where we've got 4 more sites coming up in off of Africa and the Middle East and in Europe, again, because we were able to demonstrate some of these things. But even more interesting, on October 1st, we just started $3 million in 2 more DOE-funded projects with 11 company team members. And we're now studying, well, look at all these little magenta power plants all over the world. Again, because this data is accessible, we know how to approach these sizes of problems. And actually, that's only 600 power plants, about 1.3 gigawatts. We're actually studying now about 1,200 power plants between 2 companies who are, I wouldn't say they're vicious competitors, but they're pretty substantially big competitors. And yet we have all the proper data use agreements, all the proper terms in here, the methods, so that even competitors are working with us in many different areas. And, oh, we have something where we're now starting to look at 500 sets of buildings. Again, because of these things where if you get real data from the real world, you're almost farther ahead than if you try and do a lab experiment and translate it out to the real world. What this is this application of what we refer to as engineering epidemiology. We're actually taking things from health and saying, let's use bioinformatics and epidemiology and study populations of power plants or buildings or well sites and things like that. And so what we actually do with these then is just basically pump all of our data in here. Yes, this is cloud-based analytics, and that's basically how we do things. Take care of some of the details down here. And then we can build these models that help us do 2 different things I'll show you next. The details of this you don't have to care about. But for example, this is where we can do predictive modeling of performance. So we study 60 power plants for a 1-year period, and now we can predict the range of behavior no matter how the weather is changing or the conditions are changing into the future, even in a very challenging way. And so this is all the data that we actually use. And so, for example, one of these cases, the student was working on a 50,000 dimensional problem. That's the volume of dimensions in his data. And it all boils down to identifying that there were 6 big factors that really control what's going on. It's sort of like when your doctor tells you, okay, you don't have to worry about what's on the bottom of your shoe, but maybe you should stop smoking and you should get 30 minutes of exercise each day. Those are the rank order contributors at the top of the list for your outcomes. Predictive modeling is for outcomes, okay? But the other thing is that, for example, here's a polymer material, and it's one that's very important, and we specialize in looking at things that should last 25 and 50 years outdoors, a very harsh environment. This is a polymer. Many of them would fall apart, and yet these are models in which we can basically predict out of research in our group what's going to be happening over the next 25 years with stages, et cetera, and it identifies the critical mechanisms which therefore people doing technology development can go fix in their products to extend lifetime. So those are 2 examples. One is diagnosis, right? Diagnostic modeling, predictive modeling. And so then right now we've been doing things, so one very nice thing is whenever there's data available that already exists, you're ahead because you don't have to go make it. And so in Ohio, for example, the state government has all the well logs since the past 70 years available. And so we can start looking at well logs all across the state on the Point Pleasant Formation and the Marcellus Shale and start doing analytics on these. And so these are the ones that we're looking at down here to both get to understand with our geologist friends the actual geology in Ohio and integrating all that information, even if it was 70 years old. You can totally handle those problems. We can then go ahead and apply the same kind of analytics with different data streams to drilling and fracking and getting real-time feedback to help guide the actual operation of drilling or fracking. And then the other one that's very much of interest to people is this ability to predict decline curves and studying why did this well start declining, this one seems to be working fine. It's all about studying populations of, let's go look at all of the wells and look at all their factors and identify those rank order contributors. It's sort of like I would not study just one of you to understand medical behavior. We'd study everyone in the room and quickly start sorting things out by how old are we, what are our experiences, what is our past history, and you can do it. these are the kinds of things that I think are really transformative as we move forward.
Okay, I have no slides. That was not planned, but I have no slides, and I'm not a PhD, and I didn't even stay at a Holiday Inn Express last night. But I'm going to tell you why Matrix here and is part of this innovation panel. So Matrix fits into this topic well because we spend every day delivering market-driven innovation to our global customer base. Matrix is a strategic innovation partner with our global customer base, and we use our uncommon expertise and infrastructure to solve the most challenging problems in the areas of science and technology. We have expertise in chemical, energy, and environmental technologies, as well as advanced software and systems technologies. And we work hard with our customers to enable them to take their ideas from concept to commercialization with great speed and mitigated risk at the same time. So every day at Matrix, we're working to help our customers analyze and solve technology problems, to help them achieve growth, cost, mission, and business targets. And we work with our customers to rapidly discover and help them meet schedule targets. Everything's market-driven and business-oriented. So I mentioned our uncommon expertise and our uncommon infrastructure. So our uncommon expertise is delivered by a team of over 100 experts. These chemists, chemical engineers, and software and system experts have an average of over 25 years of industrial research and development experience. Although I am not a PhD nor a chemical engineer, over 30 of our staff are PhD chemical engineers and chemists, and 2 of them are members of the National Academy of Engineering. So using this uncommon expertise, our team solves problems to turn innovation into reality every single day. We're a proud West Virginia company that has uncommon infrastructure in 2 locations here in West Virginia. Our advanced software and systems work is done here out of Morgantown, actually right here in Suncrest, for those familiar with the Morgantown area. And in that location, we have very advanced and specialized platforms, hardware, software, and networking capabilities to do a lot of big data and big data analytics work ourselves. Our chemical, energy, and environmental work, which is the vast majority of our work, is done out of the West Virginia Regional Technology Park in South Charleston, West Virginia. The West Virginia Regional Technology Park spans about 260 acres. It has 800,000 square feet of laboratory, chemical pilot plant facilities, engineering, data processing capabilities, and good old-fashioned office space for us to do our work. So this gives Matrix access to uncommon lab space, uncommon pilot plant space, and very uncommon infrastructure that we can bring to the market for other market-driven customers to use. This includes multi-story hoods, large labs, space to perform highly reactive, high-pressure, large-scale scale-up activities. This even includes the ability to scale up technologies to the point of being able to produce market development quantities for customers to actually take products to market. So Brian mentioned the fact that I'm a business guy, so why are we here? How is Matrix different? So at Matrix, we like to talk about the 4 Ds of innovation. Those are discovery, development, design, and ultimately deployment, which hopefully does lead to employment, but ultimately deployment. So American universities are the best in the world at discovery, at basic science, at basic understanding, at basic exploration. However, that next step of development, how do you take something actually to scale up? How do you make it economically feasible? How do you make sure it's market driven? Is the next step where we come into play with development and design are right in the core of our bailiwicks. So with that, I want to tell a quick story, and I think this illustrates how Matrix is Matrix core competencies, and then make an observation here at the end. So a few years ago, we had a West Coast venture-backed company that was making specialty chemicals and specialty fuels that came to us in South Charleston, West Virginia, and said, we need help scaling our technology up. They had no idea. The basic discovery, the basic research for a very unique feedstock was done that they wanted to take to a specialty fuel. But they had no idea how to scale it up, and they also said the state of California will never let us build a pilot plant anywhere. They'd never get through the piloting process and the permitting process. So they came to us and we started sketching out early design. We did some early models, and we looked at the economics, which we do in every single project we do. The first place we start is the economics. We looked at the economics and we said, we understand, Mr. Customer, that you're on Series B and you've had a few millions of dollars from venture-backed companies on the West Coast that's invested in this, but you're never going to make money. You are not going to make any money. Your technology works great. It's technologically feasible. We can scale it up, but you're never going to be competitive in the marketplace. However, your advanced feedstock does contain other elements that we can help you get out, and you can make money if you go to these specialty chemicals. So we ended up designing a process for them that was a continuous process. We did that pilot for several months in South Charleston, West Virginia at our pilot application, and they ended up deploying that technology to go after those marketplaces that were economically feasible. So that's a perfect example of the type of work that Matrix does. It's economically driven, market driven, using our uncommon expertise and infrastructure. I also tell that story because the innovation in that market, in that particular example, I think screams collaboration. And the way innovation comes about, this is not atypical in our projects that we do at Matrix. So the raw material was being produced under the auspices of a West Coast, California-based company. It was being produced in Australia. That raw material was coming to South Charleston, West Virginia in big bundles, and we were handling it with specialized methodologies and turning it in to yet another downstream material. That material was going to a university in Texas who's no longer a member of the Big 12, but we won't mention any names. Was going to a university in Texas, was being turned into a more pure product, ultimately going to Minnesota. You following this? Ultimately going to Minnesota, where the last step in the purification process was done, and then it was shipped back to California. Those were all different organizations. It was a complete collaboration, a global collaboration across multiple states. And I think now this region is presented with a very unique opportunity where we can present a bundle to the marketplace of research and development capabilities, research and innovation capabilities, specifically focused on this shale opportunity. And that's the way innovation's done these days. Appreciate it.
So I'll have a few seeding questions that I've written down, but I want to give an opportunity to those in the audience, and I know we have a couple microphones around here. If you have any questions for the panelists or for me, please just come to the microphone and I'll recognize you. And in the absence of that, I definitely have some questions for our panelists. So I'll kick it off. And the first question I have is, how will we build a collaborative network across these 3 states with about 7 or 8 different research universities and research institutions in this area of downstream? Do you have any ideas of how we might do that? So, Mark, I see you smiling.
Well, let's see, we get all the governors together. I'm not sure this is working here. Can you hear me, Mike? How about,
There we go.
can you hear me now?
Yes.
So I think it's complicated, right? I think one of the things, we have the political side, we have the R&D side, and we have the industrial side. And I think we all have to work together. And we have to have a lot of communication and get to know each other and start to develop relationships across those different boundaries. I think it can be done. I'm intrigued just sitting here. I was very intrigued by Matrix and the things that they do, and thinking, well, how can we work with them to produce things that then can go to industry and help you? So I think developing forums where we have communication and we talk about the issues in a friendly way, I think that's the start.
Roger or Greg?
I concur. I'll tell a story of something we did about a decade ago here in West Virginia, and that was, there were several economic development organizations specifically focused on commercialization and innovation that were all going in multiple different directions. And it was under the auspices of Vision Shared that we came together, and we looked at each other and said, if we keep working separately, we're never really going to get anywhere. And that was actually the foundation of Tech Connect West Virginia. And out of that came a platform where these economic development organizations are together on a regular basis, are sharing information on a regular basis, and are going after a very common platform for how do we build certain sectors of the economy. And one of the most valuable things that came out of that was just what we heard, and that is the conversations and the communication that goes on that may actually be tangential to the full mission. But we find ourselves working on joint projects and working together as a result of just coming together under some regular structure for success.
So it sounds like the first seed is planted today.
It's today.
But now we need to move forward and start a regular conversation in these areas. And Roger, do you have any examples, Case Western, and some of these larger collaborative, multi-institutional sort of collaborative efforts that are a good success story?
Yeah, even for example, in our research center and stuff, we have a lot of cases where we'll start working with one company. We'll actually do shared research, and with us, shared research is not we just send them PowerPoints or we give them presentations, but we actually have shared data sets. We exchange samples. They do research, we do research. We share things and interact back and forth. And that usually is not, getting funded is not the point of that. It's instead that it begins a strategic relationship, and in many of them we're now in our third and fourth funded project, where we then go, we now have a good relationship. They're internalizing some of these new methods that we have. And they go, but if we put our team of us with them onto this, then we will be even better off. And that's why these new 2 awards that we got were because we had already built and we're actually interacting, not just conversing, but actually interacting with a diverse set of companies who didn't actually work together previously. But we were sort of able to be not the integrator of the work, but the one who said, yes, I think this really will work as a team, and here it is. And all of a sudden now, we then have had cases where the companies go off and split off and do their own things. But it's almost that one of building the rapport and actually having concrete interaction. Right. It's sort of like shipping people PowerPoints is not exactly doing work together.
Well, Mark presented, I loved your slide on the collaborative innovation model that you had for industry, but I think it's very applicable across our region with the other universities as well. You mentioned co-locating scientists, shared facilities, funding specific research, and partnering and doing implementation projects. But specifically that co-locating scientists, I think, is something that is something very tangible that I think we can start working on. And we have faculty who do sabbaticals and those sorts of things where I think there's a real opportunity here to share ideas across the region.
Yeah, I agree with you. A number of years ago, we did it as an experiment. We worked with a company that had some real issues with metals, and they had some radiation issues with metals. So you can kind of guess what company it might be. And we had some metallurgist PhDs who were interested in the area, but they couldn't understand the problem. And so what we did is we made a deal where I paid half the salary for a summer, and the company paid half the salary for the summer, and our guy went and lived there. And the only thing that they were required to do is talk to each other and learn. And it was amazing what happened, that after that, the faculty member did some research for that company. The faculty member also wrote a grant proposal to, I believe it was the Nuclear Regulatory Commission, to do work in that specific area, sort of fundamental work, and then also did some consulting for that company afterwards and has maintained that relationship. So it was really a total success, and so I keep looking for models where that might be useful again. People start to worry about IP and all these other kinds of things, and you can really go through that stuff. You can get through that stuff and make it work. But it's about those relationships that take time, and a summer can do it.
Yeah. Right.
Because in that way, actually, what we find too, co-locating scientists is useful. It can be, if that was the only way to do it, that's difficult. Cloud tools and things that allow asynchronous co-working on things are another very useful thing. So we use Git repositories all the time so people everywhere can work on something simultaneously. Also, though, in the workforce training and education side, most of the students in my center end up going off to work with our industrial partners. And one of the real advantages, even the undergrads get summer internships, and they come into an organization which has very wise and, let's say, rather old people. For example, anyone over 30 is counted as old. And so therefore, you bring in someone who's an undergrad or even just a grad student, they can be a non-threatening change agent to people who have become rather traditional in their ways of thinking. And that's actually really beneficial. You know, it's sort of like just have them come in for a little bit and they don't say, oh, you have to do it this way. They instead just go, oh, look, I've got all these results. Are you interested? And they go, oh, yeah, maybe I should figure out how to do that.
Well, so, you know, a big part of this is collaboration that we've been talking about, but I want to shift gears a little bit as well and look forward over the next 10 years or so. And we've seen a lot of technological advances in manufacturing and computational science over the last few decades, and in particular, if you look at the last big industrialization boom in this region, technologies have advanced quite a bit. And so what technologies have now been developed that, as we anticipate, hope for, try to drive the next big technology boom in this region, what are some of those technologies that might come to bear? And I'm thinking smart manufacturing, things like that. So what are you seeing on the horizon? Or maybe I'll start with Greg.
So I think some of the biggest areas is for years there's been research in catalysis research and other things, especially this idea of taking natural gas straight to chemicals. It's been out there, it's been a holy grail, it's been around for a very long time of taking methane to more valuable products. Now we've got a huge economic impetus to make that a reality. To uplift the methane and the prices that Jim shared this morning, and to get more value out of that. I think the economics are going to pull and start driving a lot of that research. We've seen some of that in the marketplace increasingly. Other things that you're going to see as things shift, including I was struck by the fact that there was no direct propane to propylene in this entire region. Not necessarily new technology, but something that could be deployed in the region. I think just the raw materials that are here and the economics of those raw materials is going to drive some of those breakthroughs that we've all been thinking about, quite frankly, since the 50s and 60s.
And I've seen there are some exciting technologies that are out there. I look at, you know, not to name specific names, but there's a Siluria-Braskem Sasol joint venture down on the Gulf Coast, an oxidative coupling of methane that really was enabled by robotics and the catalysis development, that they use some of the technologies from the automotive industry and robotics. And so, Roger, could you comment maybe, you know, on where data and data science and sensors and robotic technology may be pushing us?
And so therefore, one of the other transformative things going forward is that we're in the second year since the federal government and also the G8 nations passed these open data initiatives. And that means that all the funding that the US federal government spends on research is becoming that you will be able to go to any paper published, click on a figure and download the data set that made that figure. So that therefore nowadays in our group, for example, a student who says, okay, I'm working on this problem and I'm gonna go make these samples and jump in the lab and spend the next 6 months, we go, no, why don't you find some open data that's available and check out your gut feelings and make sure we're doing this right. And the data might not be the perfect data for it, but that way you'll get the scouting done correctly before you invest all that time and money. And it's amazing what you can learn and do that way. The other aspect of this is about communications and sensors, and these are ones where, for example, rotating equipment we do a lot of reliability work. Rotating equipment has a lot of lifetime issues, and people would love to have predictive abilities to understand when a particular piece of equipment is showing signs prior to failure. And this is just like cities want to replace their street lighting by driving the truck once and replace all the lights before they burn out, instead of driving out a truck. The costs are gigantically different. And we now are getting to the point where we can flow these data and make these changes because of sensors and communications. So it's not just computers, it's actually this more internet-connected nature that we've gotten to. And so this almost like data-first way of thinking is one that changes things around. Instead of my saying, when I was at DuPont, I kept all my data that I ever took and had it available to me quickly online. And someone would come from a business and say, oh, we need to know about this. And a very large amount of the time I would go, oh yeah, okay, we've measured that 7 years ago and here's some initial results, and is that going to help you out, or do you need us to do some more work? And for me, it was just like, let me just get my customers to be happy and respond quickly, instead of, well, it'll take me 2 years and it's going to cost you a lot of money and maybe you won't bother me. There's a real mindset change there.
There certainly is, and we've heard today the Internet of Things, industry Internet of Things, and the connected environment that we're now starting to think about how to build plants in a much smarter way. And so, Mark, you mentioned, well, I actually mentioned in the introduction for you the Innovation Institute, and one of the big challenges in moving things from the laboratory into commercialization is the Valley of Death. And so I anticipate that with the Innovation Institute, you have some comments about how you at the University of Pittsburgh are trying to bridge that, that gap.
Sure. So at the University of Pittsburgh, what we've done is we've created, I guess it was about 1.5 years ago, what we call the Innovation Institute. And that's our central area to help promote at the university innovation and entrepreneurship. We've got a lot of brilliant scientists, but they want to have an impact out in society, but they don't know necessarily how to translate their findings into actions, products, processes. And so the Innovation Institute is really there to promote that process. It does it for faculty, and it also does it for students. I think if you'll find most universities, more spin-outs come from students than come from faculty. So one of the things that we've done is have what we call entrepreneurs in residence living in some of the units. So we might have an entrepreneur in residence in engineering. This is somebody who has come from industry, understands the marketplace, understands how to develop different kinds of processes and products in a certain sector. He goes in 3 days a week, lives in the engineering school, visits the faculty, and helps them understand, hey, you could take this and move it to here. And then we also have some courses for our faculty and students that they actually take to sort of understand the fundamentals of business, the fundamentals of startups. So that's one avenue to try to move that out. Now, a lot of times what happens is it doesn't make sense to be a startup. It makes sense to license it out and partner with a company. And so what the Innovation Institute also does is try to figure out which is the right path for whatever technology is coming out. So it really is sort of transformative, and I think most universities are going through this now, where you're trying to educate your faculty who are brilliant scientists. How can you have impact out in the world by spinning out your ideas or merging it with some other ideas and folks to bring it into a product? And then the university can help then push that forward through legal IP sort of promotion for that faculty member.
Yeah, and certainly we're following suit at WVU with specific efforts in innovation, entrepreneurship, and commercialization.
It's exciting times. I'll tell you, when I started out as a professor, I had this great idea, well, I thought it was a great idea, to spin out as a product, and I was told by the university, this was about 20 years ago, you'd have to leave the university. So you can't do that here, because that's not what we do. And so I decided I don't want to leave the university, so I just let that go. Nowadays, it's 180 degrees upside down. We want faculty to start promoting products and things that are going to have impact out there.
And then, of course, if we can build this ecosystem among our institutions, Matrix has some pilot plant facilities we can go license and use and develop that commercial pilot scale process. So Roger, one last comment. It looked like
Because another example was brought up about the maker movement, and so at Case Western Reserve University, we have a place called ThinkBox, which is a maker additive manufacturing prototyping kind of facility. It's now actually just opened in it's a 50,000 square foot building. And one of the interesting things is that the community aspects and doing things in open communities and being welcoming to people, it's not restricted to people who are just in the university. Instead, it's actually open to anyone to come in and make and build anything that they want, so that therefore, instead of being an incubator where a startup would have to pay rent, there are lots of startups that are coming and building their prototypes and just paying their use of tool time, right, and things like this. And then what we do is that we actually have the tech IP people from the law school who hold office hours in ThinkBox, and then there are computer science students doing coding who hold office hours in ThinkBox to bring these together. But now you notice that they're not just serving the needs of students or of faculty in the university, they're actually serving the uses of all kinds of people. So this facility now becomes a mixing point, which yes is of the university, but is actually of the innovation ecosystem in Northeast Ohio.
great. And we have one here in Morgantown as well. For those of you, if you have any invention ideas, come to the Launch Lab, and if you want to find directions, just email me.
And in a very similar way, there are incubation resources available at the West Virginia Regional Technology Park that are specifically focused on the chemical industry, and that's the Chemception program that the Chemical Alliance Zone has done. But that is specifically focused on new chemistries and bringing that whole ecosystem of commercialization resources and technical resources like through Matrix to play on these new ideas.
So I'm really excited by what we've heard today. You know, we have all of this energy and effort going on across the region. Now it's our job to move forward from today, start working together and build upon the groundwork we've laid today. So I know we're out of time, and the next session are the closing remarks. And so I would like to thank our panel. I really appreciate their time today. It was great.
Wonderful. Thank you very much, Brian. Wow. Is it possible to be both excited and energized and a little bit exhausted all at the same time? So, thank you very much, Brian and Mark, Roger, Greg. Fantastic. So, I'm reminded of Albert Einstein, who once commented famously that we research because we do not know. So to keep that in mind, right? So it's very exciting to think about it. I have the privilege of giving some closing remarks. I want to thank all of you for being here today and for staying. I'll do this fairly briefly. Following this, we have food and drink in the hall, and then later this evening we have the WVU Festival of Ideas. A reception begins at 5:30 right here in this same location, and then at 7:30 this evening we are lucky to have Eric Spiegel, the CEO of Siemens USA, is going to be a keynote speaker at the he's a David C. Hardesty lecture at the WVU Festival of Ideas. So if you still want to, if we haven't slaked your thirst yet, you have the opportunity to stick around for more excitement and information. I'm going to close. First of all, I'm going to do a word cloud exercise from the day. So just reflect on your own. You might pick your own, but here's some words we heard typically more than once throughout the day. Regional, generations of good jobs, triple bottom line, Westovania, true participation in teams, generational opportunity, demand destruction, ecosystem, partners, partnership, developed trust, developing trust, friends don't let friends burn ethane, nurture the cluster, believe in ourselves, the maker movement, advanced manufacturing, flagship center, dream factory, collaboration, ongoing relationship, find out what's needed, an education-business partnership, partnering with industry, 100,000 construction workers, related classroom training. We need the pipelines, a marathon, career awareness, shared resources, regional, Appalachian Basin, innovation ecosystem, commercialization, building rapport, non-threatening change agent, mindset change, regional. So, a little bit of a walk through the day. I didn't get them all, but hopefully those were some stepping stones that maybe helped you reconnect with some of what we heard. We set out for an educational experience, for a networking experience, and to really move forward in the day. It certainly has been that for me. I think there's been tremendous sharing of information. I have certainly gained new insights. I want to just share a couple thoughts as I reflect on those. We just had a peek around the corner. You know, I don't know about you, but that lights my fire when I'm in the presence of our last four panelists and we get a peek around the corner. So one of the things that came out for me was we do have a lot of assets in place. We can be awfully down in the mouth in our region about who we are. But I think if today didn't get your blood flowing, you don't have blood flowing in your veins. I mean, just think about the assets that we have in place. You heard a lot about them. There are a lot more that you didn't hear about. But that's a terrific base from which to start and to begin this regional strategy. I was forced to reflect on the rich traditions of our region. So this is not new to us. You can make a compelling argument if you read biographies and histories, and I know many of you do, and if you've been engaged in business and industry and education for a long time, and you think about Northeast Ohio, Southwestern Pennsylvania, North Central West Virginia, if you think about the rich traditions, innovation, investment, craftsmanship, on and on and on and on. Think about those stories. I hadn't really reflected, Diane, on the Rockefeller story. I read Titan twice. It's very compelling. It is a must-read if you haven't read it. But I hadn't really reflected on the deep roots of what we're talking about with folks like Michael Benedum and John D. Rockefeller. And think about that rich tradition. So this comes to us naturally. It's a little bit in our DNA at this point. This is not hard for us to do if we think about that. I think we have to begin to think about ourselves in this fashion. So what do other people see? They see a rich tradition. We heard it from GE. We've heard it from others today. As we come into this region, we're coming here because you have these rich traditions. We have been collaborating. So that came out today. We really have a lot of collaborative activity going on. One of the insights I just had in this panel, just thinking about it, one of our great opportunities, so we know, this reinforced this today, we know we have this incredible resource that's now economically feasible to extract and produce and utilize for the good of humankind. And we're sitting on it right here in a free country with great capital markets and the rule of law, right? So wow, who wouldn't give their eye teeth for that? But I hadn't really reflected perhaps in addition to that resource, in addition to the traditions that we have, the human resource that we have, I hadn't reflected till this last panel so much on the pace of change. So we live in this time of transformational change. So Mark talked about, as we talked about additive manufacturing, all of a sudden we can reimagine everything because all of a sudden we've changed the rules of the game for manufacturing. And the community and technical colleges are steeped in that, and the four universities, the research is steeped in it, the craft traditions, and all of a sudden we can be right there. And so it's not just the resource in the ground and now the ability to extract it thanks to George Mitchell and hydraulic fracturing, horizontal drilling, and all of this activity. And oh, by the way, there's lots of NGLs. Now there's lots of change going on, which the rules of the game are being changed. Distributed data. We just heard that from Roger. So just think about what that means in terms of the ability to understand and develop and make it all happen here. So Joe Eddy, Eagle Manufacturing, suggested that we should think big. We need to frame this opportunity beyond just what it might mean for our country, or for our state or our company or the particular interest that we might have in the day in, day out, but to really think bigger about what this opportunity means so we get back to Nigel Hearn's concept of generations of good jobs. This kind of concept of long-term. We heard short-term and long-term throughout the day. But I think this concept, really thinking big, thinking opportunistically, and understanding ourselves in this light. I think we've been talking the talk. We heard several people comment that, boy, it's about time we had this conference. We're starting to walk the walk, and today's part of those steps down that journey. I sense that we're going to pick up the pace pretty aggressively in the time going forward. I would suggest important for our success is building trust going forward, reaching across state lines. It's not that we don't necessarily trust one another, it's just not a pattern of behavior we've established, right? But I think you would agree that everyone in this room is a brother and sister in this journey, in this opportunity, and sees it, and I hope that you've established some relationships and that we can continue to build going forward, because I'm convinced that the world is our oyster if only we pursue this on a regional basis, and that's why you're all here. So in terms of next steps coming out of here today, we are going to make available to you information that you've seen. We're going to check with all the presenters. Don't think anything, several of them said this is on our website, this is not proprietary, but we're going to push information back out to you. We're going to solicit your input and thoughts and reactions, not only to the conference, but what should be some next steps. Now keep in mind, we've had 3 governors sign an historic agreement in our presence pledging regional cooperation and collaboration, and they've characterized it as a first step. They've identified specific working teams in 4 areas. You can actually locate a copy of the agreement itself. That's a public document we're proud to display. I know it's posted here on the governor's website here in West Virginia, governor.wv.gov. Just go on that website. It's the governor's website. I'm sure that's true for Governor Wolf and Governor Kasich and Lieutenant Governor Taylor as well. So take a look at that. If you're curious about what they signed, take a look at that. But we want your input, because we have to make this, we have to act on what we heard here today. And I think that's going to occur informally, as we just talked about, but I think there's going to also be, for our ultimate success, it needs to be a little bit more systemic. So give us your ideas and suggestions. I have suggested that this is the first annual and that the second annual will be held somewhere else in Westovania, and I'm hoping that happens. We'll see that competition between Pennsylvania and Ohio play out. Get out your gloves. But react to that concept, talk about the other things we should be doing. Who are the other people that should be on the panels? What other topics should we be pursuing? And what are those steps, perhaps, between annual summits where we can make things happen? In closing, I want to thank a lot of people who made today possible. This was this is well over a year in the baking, if you can imagine, and just kind of getting this all pulled together. But I want to, and a lot of people made it happen. But Vision Shared, led by Corey Dennison here in the front row, our executive director, the entire board of directors of Vision Shared, the Benedum Foundation, Mr. Regionalism, Pat Getty seated over here. Thank you, Pat, for your true leadership in the region and for all that you do and for your hard work on this conference. The Allegheny Conference, Ken Zapinski, Ken's over there sitting beside Pat. Phenomenal. Team Neo, Paul Bouillet right here in front. Scott Rotruck. Scott makes everything happen, and he's very quiet. He does it, and there's this picture of Scott, for those of you who don't know Scott Rotruck, on West Virginia Executive Magazine many years ago, and he's in a convertible, and he's got there's a tie flashing behind his neck like a, or it's, I don't know, what was it, a tie or is a kerchief or something? But, Scott is always racing with energy and enthusiasm to the future, and he has been a big part of this. We had phenomenal speakers. I hope you will agree with me. Let's please thank them once again for all that they did. People everywhere in the world didn't have the opportunity we had today with our speaker panel. The Adventure Group, LaDotta Taylor down here, it's an entire group that makes magic happen. Someone has to make it happen, LaDotta. LaDotta, wave for us. LaDotta has an entire group, but especially Sarah Bjorko. Sarah, where's Sarah? She's out doing her job, getting us, back here. So the planning committee. Again, you're all invited to remain, continue to network, give us the feedback. We'll be reaching out to you. Thank you for your investment. Thanks especially to our sponsors. You see them again in front of you. They make great things happen in our region all the time. This is important. And I hope to see you at the Festival of Ideas. Thank you. We are adjourned.